All right, folks, just want to let y'all know you guys are being recorded now, and it is recording. So, yeah, but yeah, we're back. Still talking about the CCNA 200-301. Big session. This section is going over Unit 8, which is named Network Management, and touching on CDP and LLDP, both that reside at Layer 2. Right. So first, we can go ahead and touch on CDP. I just want to touch on a little bit of theory. CDP, of course, Cisco Discovery Protocol. From a Layer 2 standpoint, frames are sent in between Cisco devices to share information about the device. Plain and simple, right? And so what somebody like myself or Nick or Kelvin can do is we can use CDP, and what the routers will do, they'll exchange information and receive information as long as it's on the same broadcast domain as another Cisco device, and it will lock into what they call a CDP neighbor table, information about that other Cisco device that's on that same broadcast domain or same physical link, right? So then you'll see it. It'll be, I apologize, music is still playing. I'll turn that down. You can actually, and I love the word that Kelvin used earlier before we started recording, you can actually map out the network and see what's connected where and where it's connected to what, right? Real quick before we jump in and start looking at stuff, I'm sure you guys saw, if you guys didn't, the last session that we had was a benchmark, a CCNA benchmark for Jaquan and Kiera, some of the great folks that I met in my other group that I'm in. And so one key piece that I had to share with them is that everything at Layer 2 stops at a Layer 3 boundary, right? What does that mean? Let me get my handy dandy pen, right? And I'll show you guys what that actually means, right? Right, broadcast domain, boom, Layer 2, right? Broadcast domain, boom. Broadcast domain, boom, right? That Layer 3 boundary that sits right here. Okay, we got somebody else that jumped in, right? Layer 2 protocols, Layer 2 anything, don't go beyond that, right? So anything at layer 2, anything at Layer 2 between, for example, R3 and R4, R5 is, let me go ahead and mute you. Anything coming from, for example, anything coming from R3 and R4 that exchange Layer 2 frames, those frames that are shared between them, right? R3 is not going to see Layer 2 frames from R5 because it stops at that Layer 3 boundary, right? Wherever Layer 3 is at, it's going to stop. It's not going to extend unless you configure it. Use some type of technology to extend Layer 2. But in this case, by default, and of course for the CCNA, you guys would have to know is it doesn't extend, right? So that's why I use the specific terms. Cisco Discovery Protocol can be used depending on the broadcast domain, right? It can be used to find all devices in your broadcast domain as long as CDP is running, right? And we'll take a look at that shortly. So again, you'll be able to see a lot of detailed things, right? And CDP is our first option. We're going to look at LLDP as well, which I love. LLDP. It gives a little bit more information, a little bit more detail. But let's go ahead and look at CDP. What I told you guys is those frames that we have you exchange between Cisco devices are done at Layer 2. So let's go ahead and first and look at my favorite program, and let's take a look at what's on the wire, what's being sent all throughout the wire. So I'm going to go ahead and open up a packet capture, and we're going to go ahead and take a look at R3 and see what is it receiving on its wire. Give it a second. Let stuff pop out. Second. Let it fluctuate. See what happens. Give it a second. And while that's doing that, let me go ahead and open up R3. Here we go. We got R3 open. Excellent. So it's good to go. Let's go ahead and check there we go. Let's go ahead and check that, and let's open that up. Open up R3. So as you guys can see, right, we're doing a packet capture, right, on the interface, right? The interface, I believe it's interface gigabit 0/0 on R3, right? And again, these packets are sent via layer 2. They're not sent via layer 3. Again, CDP is a layer 3 protocol, right? And so this stuff is sent, right, on that same broadcast domain, right? That it's that, you know, wherever it's connected to physically, right? We'll take a look back at the diagram. But as you can see, it has all this information, right? It has the time to live. It has the checksum. Of course, it's checking both sides if it matches, right? It has the device ID. Of course, this CDP packet actually, CDP frames, which is at layer 2, it's sending information about itself. So you're going to see it, share the software version, a lot of things, right? And all these things that we're looking at, we're going to be able to see it on the CLI as well, right? But of course, this is what we're seeing on the wire, right? And like I told you guys, right? Typically, packet captures will see, oh, where's the, you know, IP address header, what have you. Again, CDP runs at layer 2. So we're only going to see stuff regarding layer 2. Okay, so we're going to see MAC addresses, source and destination. Of course, we're going to see that. We're going to see, of course, some stuff about logical link control. And of course, then we're going to jump into the actual package, right, that's inside that frame, right? And that'll be CDP, right? And so let's take a look, right? Let's go ahead and hop on, you know, R3, and let's take a look at look at that CDP neighbor table and see if the stuff that we see within the packet capture that traverses on the wire, if that looks the same. And matter of fact, since we're looking at R3, we can actually, so we're looking at that packet being sent from R3, we actually need to look at R4 to see if it matches from what it has. Let's go ahead and do that. Go ahead and log in. Okay. And that command would be show. Go ahead. I like to do this question mark. Right here, of course. Man, that says CDP, so CDP information. So I'm going to go ahead and put that in. I like doing question marks, so if I don't know something, I have to figure it out. And of course, we have multiple options, right? We can look at different entries, CDP interface, but I want to look at the neighbor table. So I want to look at the CDP neighbor table. I'm going to go ahead and put neighbors, okay? I can go ahead and tab it out and press enter. All right. So we have here, there's a lot that's in this table, but I can go ahead and break it down and slow it down a little bit, right? So this is a real, without it saying CDP neighbors, show CDP neighbors brief, this is a brief table of the CDP frames that R4 received from its neighbors that it's on the same broadcast domain with. And so we're going to be looking at R3, right? Device ID, R3, right? That matches up what we have right here, device ID being R3. Local interface, right? What does that mean? That means the interface that's on R4, where it learned the device ID of R3, right? Hold time, CDP, they have a specific hold time, right? And so whenever it receives another CDP message, hey, that hold time gets reset. And that theory of hold times, what have you, that's remember to keep that in your mind, because that's going to follow you all down the road within your CCNA studies, CCNP studies, if you decide to go that route, when you're learning about OSPF, you're learning about spanning tree, what have you. Hold time is a very important thing. And then we have capabilities, right? Capability, RB, right? What the hell is RB? Well, they have capability codes up here, right? And they describe what that device ID, that device that you learned about on that broadcast domain, what it's capable of doing, right? So we know R3 is a router, right? What these codes are telling me is it has capability to be a router, right? And it also has a capability of being a source root bridge, right? And you guys are probably thinking, hey, this is a router. What do you mean it has a possibility to be a source root bridge? There are functions, right? We can make some interfaces on an actual layer 3 router be a bridge, but again, beyond the CCNA, forget I even just told you. I just wanted to go ahead and give you guys some context. So most capability codes, it'll have codes. You can look at it there and compare and see your device and say, hey, R3 is capable of maybe being a switch, being a router, et cetera, et cetera. Or maybe a host is pushing CDP packets, which will kind of be freaky, but we'll see it say, hey, it's a host or it's a switch or a router, right? So capability codes explain that, right? The platform, typically it'll tell you if it's like Cisco, what have you, depending on the software version of the device, right? The image that I'm using right now to explain to you guys how this concept or this theory works of CDP, it's very limited. So we're not going to see any values for the platform version, but in a new, maybe Cisco 9000 switch, you would see that filled in, okay? And that would typically have, either Cisco, Aruba, etc. Okay? Now, port ID, right? Last but not least, that's on this brief list of CDP information, right? That's telling us remotely what's that port ID, okay? So on R3, those CDP packets are being sent out of gigabit 0/0, okay? And so we can match that right here, port ID 0/0, okay? So all that matches up, right? But we don't have to stop there, right? We can go ahead and say, we have a brief table, which is by default that show CDP neighbor shows, but we also could look at a detailed table, right? And this typically gives you more information that you can use to maybe map out your network on a whiteboard, right? Because maybe you're logging into switches and you're new to the organization and your first day is a fucking shit show, right? And you have to troubleshoot an issue and you only have access to the first switch, okay? And so, or first router. So you can use, like Kelvin was saying, of course, he uses it, for troubleshooting as well for his job, is that you can use CDP or LLDP to find what's connected to what, to device that you're on, what's connected to it, and of course to hop to different device and build like a little map for yourself of how the networks look and what's connected to what. So if we do show CDP neighbors detail, right, it's going to give me a detailed list of its neighbor that it's learned about. So I'm going to go ahead and minimize R4, right, just for the sake of compare and contrast, and I wanted to go ahead and take a look at R4, but I went ahead and opened up a frame that the device ID is R4, right? So remember this, we're going to go ahead and take a look at this. I'm going to go ahead and open up R3 and take a look at its detail table. So show CDP neighbors detail. Let's take a look at it. Let's go ahead and break this down, right? So if we take a look at it, right, we have device ID, which we see right there, right? Device ID, R4. We have the entry addresses, IP address 192.168.12.2, right? Again, this is a router. For those that just showed up late, these are routers that are connected to each other, not switches, right? So R3 is connected to R4, and R4 is connected to both R3 and R5, just to give you guys a little map in your head, right? Right now, I'm just looking at R3 and seeing what information it learned about R4, right? And we're looking at this packet capture to see what's on the wire and see if what's on the CLI matches up to what these devices are sending to each other via CDP, okay? So IP address, 192.168.12.2, we can go ahead and see in one of these fields, it's right here, okay? And, the great thing I like about this, of course, with Wireshark or what have you, is with the show CDP neighbors detail, right? It'll show us the lowest IP address in show CDP neighbors detail, right? But if we did a packet capture, it's going to show us all the addresses that it learned, right? Real cool stuff about Wireshark. And of course, like I told you guys, real limited software. And of course, whenever we looked at the show CDP neighbors, which was a quote unquote brief version of this command, right? It didn't show us the platform, but you can see it learned, hey, it's Cisco, right? It's a Cisco device or what have you. We know this, boom. And where can we see that in the packet capture? It's right here. See the software version, Cisco iOS. So it's able to read that. If it was an Aruba, if it was a Fortinet, or maybe a FortiSwitch, if it was a HPE or Arista data center switch, it would see all of that, okay? As long as it's running, CDP, it would learn that information, right? And LLDP as well, and we're going to touch on that in a second. So as you guys can see, we can see that information. We can see, it's giving us detailed information, advertisement version, and it gives us, more information that we saw in the brief version of the command. And for those that came late, if we look at the brief version of the command, only gives us a little bit. We don't see a platform, local interface, of course, the interface that's on this device, and the port ID, this is what is sent from the remote device. And we can compare that port ID over there, right? You can see it right here in the packet capture, hey, gigabit 0/0, right? And that's a good, if you don't have Wireshark and maybe you're in a high stakes situation troubleshooting, you can go ahead and decrypt this, this show command and say, hey, the device that R3 knows about is R4. R3 learned about it on its gigabit 0/0 interface, right? The hold timer is 178 milliseconds currently, right? If it, gets another CDP frame, it's going to go ahead and reset. It is capable of being a router and a quote unquote source route bridge right here. But again, these capability codes are your best friend, right? You can take a look at that whenever you're taking a look at this table. Platform, of course, since this is a limited version of Cisco iOS, this command, I found out that it doesn't show the actual platform in the show CDP neighbors, but in the show CDP neighbors detail, it gives you the full platform. And of course, that remote interface from the other side of the remote device, 0/0. Plain and simple, right? And of course, for the CCNA, whenever you guys are studying, you'll probably get, and please somebody confirm with me, it's been a while since I took the CCNA, let alone my CCNP, but they will typically give you a screenshot of a show command, and they would say, what is that device capable of? And you'll have to be able to, maybe they'll have this blanked out, or maybe they don't, and you'll be able to say, hey, it's capable of being a router and a bridge, right? So real simple enough. I hope that was simple for you guys to grasp. Any questions so far about CDP?
So to answer your question, yeah, you will see something similar to that on probably the exam. It might give the little bit of it, maybe even without the codes, and you had to figure out what the hell it's doing.
Mm-hmm.
But pray to God you're able to zoom in.
Yeah, exactly. So, Pete, thank you for that. And yeah, you can, again, if you don't have visibility in the network, this is a great protocol, great feature that's typically on Cisco devices, and you can enable it on, I believe, Aruba, and I believe some vendors have it, where you can enable it, where you can go ahead and enable it, and you can map it out just for your network, right? But in the industry so far, I've seen people disable that and go ahead and enable LLDP, right? And so that's what we're going to talk about now, right? You guys are probably thinking, okay, what's the big difference? And while I pull this up, you guys will see it. What's the big difference in between CDP and LLDP, right? So CDP, it's Cisco's, right? Cisco Discovery Protocol, right? It's Cisco's main proprietary protocol. LLDP, it's open for the world, plain and simple. Okay, so go ahead and do this. So we're going to go ahead and take a look at LLDP, because typically on most of the devices that you guys will probably see in your environment, I know Makita was talking about how she was working on Fortinets. You guys probably touched on Arubas, maybe Extreme switches. Most of these devices don't have a function to where you can enable, where you can go ahead and enable CDP, and the only option that they have is LLDP. So you can use that as well, right? And it's typically read the same, exactly how I just showed you guys how to read CDP and how to break it down and how to use it. It's the same exact thing, okay? So let me go ahead and pull this up, right? I actually didn't pre-configure LLDP. I wanted to go ahead and do it because this is on Cisco devices. You have to go ahead and enable, okay? So let's go ahead and knock that out right now. I can go ahead and do it in global configuration mode. And it's a simple LLDP run, okay? All right, so now you see, of course, frames are being sent out. Let me do the same thing. Switch to. Okay. All right. So I have it rolling. Okay. And so, as you can see, it's kind of blurred out and within the packet capture. So I'm going to go ahead and minimize this real quick. But let's go ahead and do a filter on this, on the wire side. Let's just look at LLDP packets. Okay. So break this down. Let's go ahead and can you guys see? Do you guys want me to zoom in a little bit?
I can see it.
You can see it? Okay. Zoom in a little bit. I'm an old man. Let me go ahead. Go ahead and pop up. All right. There we go. There we go. There we go. And perfect. Okay. That's it. All right. So let's go ahead. So let's go ahead and take a look at what we're seeing here. So we see link layer discovery protocol, right? It tells us what's that, frame header and what's entailed within this payload. Okay. So link layer discovery protocol, right? It gives us way more information, right? Chassis subtype, it's telling us the MAC address and its ID. It's giving us what they call TLVs, right? TLVs are type, length, and value, right? And they're typically called TLVs in many other settings, right? And you guys will probably see that in different protocols whenever you're studying from a routing standpoint. But these TLVs, and a network management standpoint as well. But these TLVs, right, they're very important because they give way more granular information than what CDP does, okay? They're gonna go ahead and say, hey, what's this, what's that, what's this? It's similar to a network management system if you guys played with that, and those OIDs send back specific values for the specific OIDs, okay? So there's a port description TLV, right? System name TLV, and we'll take a look at that. System description TLV, system capabilities TLV, and a management address TLV, right? What does that mean? The port description is gonna have a type, a length, and a value. The system name is gonna have a type, a length, a value, right? A management address is gonna have a type, a length, a value, and so on and so on and so on and so on, okay? And so if we look at here, right? If we look at the port, we have a type, length, we got the value, right? That's literally it, right? It's going to have TLVs. But how does it look whenever we're looking at maybe the device? Because we're not going to be able to, maybe we're not going to be able to go ahead and take a look fully at Wireshark. We may not have access to Wireshark, and maybe we need to troubleshoot immediately. So this frame, this is referencing, if I'm looking at this correctly, it is referencing, this is an LLDP frame for switch 1. So I'm going to go ahead and look on switch 2 and see if everything matches up. Go ahead and clear it out. Let's do a show. LLDP, right? Of course, I love the question mark because, of course, if you don't know, you can always find out by the question mark. And we're going to go ahead and look at that LLDP neighbor table. So we're going to go ahead and put neighbors, okay? Basically the same damn thing as a CDP neighbor table, right? It's going to have the device ID, the local interface that's on this device. So if we're looking at switch 2, it learned about switch 1 on gigabit 0/0. Hold time currently is at 120, waiting to receive another LLDP frame. Capability is a router, okay? I have that right here, even though this is between 2 switches, right? So is it off? Not really, right? But again, this is a brief. Even though we didn't put show LLDP neighbors brief, think of this in your mind as this is just a brief summary of the LLDP neighbors of switch 2, right? So we got that, and of course the port ID. we can go ahead and match that with gigabit 0/0 on the other side. Do we see it here? It's right here. We can see it, right? So let's go ahead and dig deeper. And of course, similar to CDP, we have a detailed table that we can look at, right? So show LLDP neighbors detail. We can also look by interface as well. So that's always fun. Let me go ahead and blow this up since we're only examining switch 2. Okay. So a lot of stuff, right? So, and what I like about this, right, because I'm a real peculiar person, I'm sure you guys can, you know, relate. Of course, as you guys move up the ranks, you have to be peculiar as far as the data that you get and data that you look at when troubleshooting. It's LLDP organizes it very well, right? It tells you local interface, gigabit 0/0, tells you the MAC address, right? Or quote unquote chassis ID, right? And you can match that up. You're looking at that here. Hey, that value matches up, right? And of course, you know, similar things that we saw within CDP, a little bit more organized, right? And of course, like I promised you guys, LLDP detail shows in detail the capabilities, right? Bridge and router, right? So again, these two things, LLDP and CDP, again, they have its pros and its cons. LLDP a little bit more organized, a little bit more detailed. CDP, it's great. You know, you can map out a network with it as well. Both powerful tools. I believe CDP is typically not used in most networks. I know we, for my job, we don't use it at our network just because it's too much vulnerabilities. LLDP does as well, but we can go ahead and lock down LLDP with a few other security measures or what have you. So we can go ahead, take a look at it, look in detail, has a look, and just like how Pete put in the chat, and similar to what Kelvin does, and of course what any of us does that typically troubleshoots on a day-to-day basis, is you can get a whiteboard and typically with this command map out your entire network if you only have access to one device. And let's say if you have just an IP address of that next device, you can start SSH into the next device. That is how much powerful LLDP and CDP can be for your environment if you use it. And of course, what you'll have to know for the CCNA. So not really, of course, you got to know the super details. This is not the CCNP, it's the CCNA. Know what it is. Know, of course, the, you know, some of the minute details that they show up with on those chapters, right? The network management chapters. LLDP, what it is, what TLVs are, right? CDPs, knowing it's Cisco proprietary, know how those show commands look like, right? Know what the neighbor table looks like, the difference between detail and just the regular neighbor table, and boom, you should be good for that exam. With all that said, any questions, guys?
Seems pretty straightforward to me.
Cool. Anybody else? Okay, I'll take that as enough. So I wanted to show you guys this because, of course, our last topology, let me go ahead and close this packet capture, and I can go ahead and show off all our devices. The last topology where we did our benchmark with Kiera and Jaquan, and they did a great job, by the way, right? We started, we touched on the path of the packet. Kelvin and Twan and a couple other folks, I know this looks familiar. Nick and Makita, I'm probably going to bring you guys through the gulag of the path of the packet, right? But, with this, right, has network admins, engineers, what have you. We have to know what the path of the packet is, right? And the golden rule is a source and a destination, right? And once we get right here, layer 2, it gets funky. It gets funky because we're going to have to do spanning tree. And what if we didn't have this diagram of our networks and you're trying to troubleshoot a spanning tree issue? You have to use other methods within layer 2, maybe CDP, maybe LLDP, load into these devices and see what's going on, right? So that's why I wanted to go ahead and show you guys what this looks like, because we're going to go ahead and, just like Antoine shout out there, there's going to be a big spanning tree challenge. Might make it a yearly tradition. I don't know what what one of my favorite DC characters I'm going to use to build the diagram, but I'm not just going to include spanning tree. It's also going to include some other layer 2 protocols, right? So I just wanted to take tonight to go ahead and touch on some of those line items within that CCNA 200-301 syllabus. And we're going to go ahead and take a break and have fun this next session 2 weeks from now and do the pathway packet. So Makivia, I'm sorry, and Nick, you guys get ready. All right. Well, folks, this was fun. This was great. I'm not going to hold you off much longer. The recording will be on YouTube in about 15 minutes, and you guys have a great night.
All right.
Thank you.
All right, gents.
All right, have a
All
good
right,
night.
ladies and gents. You guys have a great night.
guys.
Thank you.
Good one.
Too.